Hello, my dear students. Welcome back to my class. In a series of learning data structures through C, in the previous video, we discussed about linked list. We understood what actually the linked list is. Well, in today's video, we will be discussing about the actual definition of linked list, followed with dynamic memory allocation and the operations that what we can perform on linked list. So we actually understood why we require this linked list, and we understood the difference between static allocation and dynamic allocation. In today's video, we will proceed with these topics which will make you understand why this linked list is used actually and what actually this linked list is, followed with the supporting concepts for linked list, that is dynamic memory allocation, how to allocate the memory dynamically, and what are all the operations we can perform on linked list. So those who are new to my channel, please subscribe to my channel and click on the bell icon, and you can get the notification of all the videos. Watch the video till the end, do not skip the video, and if you like the video, please click on the like button and share the video to all your friends. So let us understand the actual definition of linked list. So we have understood why we require linked list in the previous video. Now we will see the actual definition of linked list. So what is this linked list? A linked list is a linear collection of data elements called nodes. So we use a special word, a special object, we can call it as, which is node. So here it is going to create a collection of nodes, and the linear collection of these nodes is linked to each other. So it is called as linear collection. Linear means one after the other. So here we have to create nodes, and these collection of nodes are interconnected to each other, hence the name called as linked list. Create a list by linking to each other. So those nodes that what we create are of user defined type. So how to create that node? How actually we can design the node? All those things we have to see in the next part. So one thing that you need to understand is it is the collection of nodes linked to each other. And the linear order that what we create here in linked list, it is with the help of pointers. As I said, the memory is allocated randomly. So the memory has to be referred with the help of pointers only, right? So pointer of the special variable which holds the address of another variable. So we have seen how this pointer variable holds the address of another variable, and these variables are of normal fundamental type. But now we need to see a user defined data type, and we have to make the pointer to point to that user defined data type, means a pointer should also be of user defined data type. How to create that pointer, how to create the node structure, the next part. And if you have any doubts regarding pointers, you can just get into the program that is list of C language. So you have the C programming language list. So you can get the concept of pointers there. So pointer is a special variable, how it is going to hold the address of another variable. You have a playlist of C language in my channel. You can go through that playlist. The C language playlist, you have the concept of pointers. So if you have any doubts, you can just go through the concept of pointers. How this pointer is going to help here in linked list, we will be seeing in the linked list topic. So how this node looks like and what actually this node is. The node contains two parts. It contains two parts. One is data part, the other one is the link part. Data part means some data, some information. Link part is the address of next node. So this node we need to create, and this node should contain two things. One is data, the other one is link, the address of the next node. So even that node, whatever node we create, that node will have its own address. So for example, the address of this node is 100. So in this node, so we need to create a structure in such a way that it holds two things. A normal variable can hold only one value and an array can hold multiple values but of the same type. But here we have to create a structure in such a way that it contains only two parts. One is data part, the other one is the link part. So for that we have to go with structure. So you have to have a glance on structure also. And once again, if you have any doubts with structure, you have to please go through the playlist of C. You get the details of structure. How to create this node, we will be discussing in the next video. Right. But this data part and link part, hope you are understanding. A node will have two parts. One is data part, the other one is link part. So in the data part, we fill the data. Some process data, it holds some information also. Initially data, and we can also process that and we get some information, right? Data, some data. And link means the address of the next node. So like this, we will be creating nodes during runtime. And in order to create those nodes during runtime, we have to make use of dynamic memory allocation. How to create that nodes? We have to see the concept of dynamic memory allocation. And in the link part, we will be having address. So when I am saying it is having address means, see here, pointers concept comes into picture here. So one will be data, the other one will be link. So we have to create a structure in such a way that it contains two parts. One is data part and the other one is the link part, which is the address of the next node. So now let us see how to create this node structure. Means before we learn how to create this node structure, we should know something about the dynamic memory allocation. So let's get into the concept of dynamic memory allocation. We have seen what is actually the dynamic memory allocation in the previous video itself. Now we will see how to create this node structure using this dynamic memory allocation. As I said, in the linked list concept, the memory will be allocated dynamically during runtime. So how to allocate this memory dynamically during runtime? We have to make use of some functions here. So here we have two standard library functions. So we have two standard library functions called as calloc and malloc. So with these two functions, we can allocate the memory during runtime, that is during execution time. So with the help of these two functions, the memory is allocated dynamically. Means who is going to point to this memory? So pointer comes into picture here. So for memory allocation, dynamic memory allocation takes care. It will use the calloc and malloc function and allocate the memory dynamically from the free store, from the heap of memory. So we have two memory. One is the static memory, the other one is dynamic memory. So dynamic memory you are going to get in the free store. A heap of memory will be there, and from that heap of memory, the memory will be allocated, and with the standard library functions we allocate the memory. And pointer will be made to point to that memory. So how a pointer is used, how these calloc and malloc functions are used, let's see now. So these two standard library functions, calloc and malloc, helps to allocate the memory dynamically, that is to allocate the memory during runtime. How to use this? So syntax is like this. We have to make use of the pointer variable. Data type asterisk means a pointer to that data type. So if I just want to store integer data means, I know I want to store integer data means the amount of memory that what the system has to allocate, I have to specify that. So you have the size of operator, which will give you the size of the data type based on the processor that we used. It may be 16-bit machine or 32-bit machine. Say it may consume 2 bytes or 4 bytes for one integer. So I want to store one integer data during runtime, and the amount of memory required by that is calculated with size of operator. I say size of data type. So that much amount of memory I need to collect from the heap memory. So from the heap memory, I am going to collect that much of, say for example, I am going to collect 2 bytes of memory. I am going to fetch 2 bytes of free memory that is randomly obtained. So 2 bytes of memory allocated with the help of malloc function, and this 2 bytes of memory will be pointed to by a pointer of this type. So if it is integer means the pointer should point to 2 bytes of data or 4 bytes, depends on the machine. If it is float means it has to point to 4 bytes of data. So size of operator will give you the amount of memory to be fetched. With the help of malloc function, that memory will be allocated, and this pointer will be typecasted to this type to point to that memory. So I have a data type pointer, a pointer which is going to point to that memory, and that address will be held in this pointer variable. So a typecasting will be done. A pointer variable will be of that particular type. See, we all know a pointer variable is a special variable that holds the address of another variable, but it should be of the same type. Right. So if it is integer variable, then I have to create integer pointer only, so that an integer pointer can point to 2 bytes of memory. If it is float variable, then I should have float pointer only, because the float pointer can point to 4 bytes of memory. So in the same way, so this malloc function is going to allocate the memory, and it is made to point by a pointer. So a small example, you have an integer pointer, so means it can point to a location that can store integer type of data. So it can point to, say for example, 2 bytes of memory, and that pointer is pointing to 2 bytes of memory means I can store integer data there. So I just say integer pointer malloc function from the heap memory. I am going to fetch the size of int, data type int means 2 bytes. So I have some memory, I am going to fetch this 2 bytes of memory. So for example, I got 2 bytes of memory, say 101 and 102. So size of integer, you allocate a memory of size of integer means 2 bytes of memory I allocated from the heap memory with the help of malloc function. Integer pointer means you typecast that to point to that location, means this pointer address, say for example 101 will be held in this pointer. So you have a pointer which will be typecasted to integer pointer, So you have pointer which can point to this location, means the first address, base address will be stored. So 101. So pointer is pointing to this location. Here I can store integer data, some data, 20, something like that. So this is how we create the memory runtime, during runtime memory allocation. That is what dynamic memory allocation. Both calloc and malloc does the same thing. These two functions are used, the standard library functions that what we use for dynamic memory allocation. So this pointer variable ptr is pointing to this location, and this location I have obtained during runtime. So here we saw integer pointer pointing to an integer location, but I need to create the node structure which is required for linked list, and that node structure is the one that contains two parts, and that two part has data part and link part. The link part will be the address of the next node. So here I should have a pointer that is of node type. How to create a pointer of node type? How to make the pointer point to that node type? How a memory is allocated with malloc? We will see how to create a node structure first. So first of all, we should see what are all the operations we can perform with linked list. And then we will go one by one. So hope you have understood this very simple function, calloc and malloc. In the place of malloc, I can use calloc also. And these two standard library functions helps to allocate the memory dynamically. With the help of pointers only we can achieve this. Malloc and calloc alone can't do anything. They have to take the help of pointer. See, once the memory is fetched, there must be someone who is going to point to that memory, right? That is what pointer is going to do. And the pointer should be of the same type. So here we create a node type of pointer so that it can point to a node to store node type of data. Node type of data means data handling. So I should allocate a memory from the free store. To store node type of data means to point to that memory, I require a node type of pointer only. So how to do that we will see. So first of all, we will have a list of all the operations that what we can perform on linked list. Here is the list of the operations that what we can perform on linked list. First of all, we need to create a node. How to create a node? It's quite a complex code that we need to discuss. A complete video is required for that, like how to create a node. And that I'll be discussing in the next part of this video. Means the next video I will be discussing about how to create a node. Because creating a node structure is not very simple. And to understand that creation of node structure is quite complex. So it requires a complete video. So in the next video we will be discussing about creating nodes. So now we have learned what is linked list. So it says it will be having node. The next we learned about dynamic memory allocation, which helps to allocate the memory, and about the pointer we understood how the pointer is pointing to that memory, all those things. The next thing is how to create that node structure and how to make the pointer to point to that node structure. That is the major part in linked list. The first major operation in linked list is creating node. So a different object we need to create which contains two parts. How to create that? Obviously it is structure only, right? So have a glance on structure before we get into the next video. Okay. Then traversal. Traversal means visiting every node one by one. Insertion means inserting a node. Say for example you have 4 to 5 nodes already and you want to insert a node to that linked list. Means I can insert in different places. It may be beginning, it may be ending, or it may be in between. Right, in the same way deletion, deleting an existing node, the beginning node or ending node or in between node. Searching, searching a particular node. Merging means combining different linked list nodes. So this is the operations that what we can perform on linked list. So we will be discussing about this creation of node, which is the most major operation in the linked list, in the next video. So hope you have understood all these topics. Any doubts you can just ask me in the comment box. I can clear those doubts. So that's all for today's video. See you in the next video. Till then, take care. Bye bye.